So far we created an app that displays a single quote, completed iteration number 2. So on to iteration 3. The main difference here is we want to bring in a list, or have the app recognizes a list of quotes and then use that list to display the single quote that we see in front of us. Um, in an essence, there is no, and as we discussed in the overview, there's no change in the view. The view's still gonna be the same. Uh, where the data or where the code is coming from, and I called it the data, that's what it is from the software aspect, the data that the app needs to deal with. Where the data is coming from or where the code is coming from is what will be different. Here in this app, the code came from, and now listen to this word, hard coding. I hard coded the code into the text property of the label component. So this is fixed or static, meaning that anytime the app work, regardless of the location or the device or the user, that hard-coded text or hard-coded string or hard-coded data will not change because it's hard-coded. So I want to create the data, but I also want to be conscious not to make it hard-coded, because one option could be is that I put all the 5 quotes, hard code them into the controller, and I don't want to do that. So I'm going to create a file, put the quotes in the file, and then have the controller speaks to the file. The primary reason I'm doing this is to follow software practice, best practice, and to support that the data change. The idea here is that the controller, which is the brain or the logic, should be isolated from the actual data itself. It should know where it is and go grab it, know its type, but it should not really be connected or coupled or tied to the value of the data. So the first step we want to do is to add the quotes in a file into our app project. So if I go to the file and say new and new file, or you can click the command N, or you can right click in the project navigator and say new file. All of these will take you to the same place. So new file, and then the template will come. Again, it's a similar template to the one we had when we created the project, iOS and the different platforms. So we are with the iOS, different types of files, and one of them is a resource, and that's what we're looking for. We want a file, a resource file. So a property list file is an empty, and this is extensible markup language property list file. So this means that this file follows the guidelines of this language, which is basically a key value, as you will see in a moment. So we create a property list file, and then next it will ask you what do you want to name the file. So I'm gonna call it quotes. You can call it quotes list also, or you can give it any um, name you want. The name is very important because that's how the controller will find it later. So very important to know what name you will give the file, and it is case sensitive. Um, and then the file, we want to keep the file with the project, and then you can group the file within the groups you see in the navigation controller in the navigation area. So I'm gonna group it with the same group and then say create. So now I have a property list file called quotes list, and the extension is plist. And when you look at the file, you see it's 3 columns, key, type, and value. Under the type, there are 2 types, an array, which is a single dimension array that's automatically indexed from 0, 1, 2, 3, or a dictionary, which gives you the ability to do custom naming. We're going to work with dictionary in project 3. For now, we are in the array. And then, so now we define that the content of the file is an array. So now we can add items. So once we add item, you see here it's item 0. And this is the type. So you can provide different types. And one of the types can be an array. So just a hint on the side, if you decide to do one of the if you want to add later on, you can add categories by using an array inside an array. For now, we have a string, and then you say, what is that string? So let me add my first quote, begin with the end in mind, Stephen Covey. And then you can hit enter and another enter to create another item, or you can have the plus and the minus. What's very important here is add the quotes you want. Make sure the type is always a string, and add all the quotes you want. I gathered some quotes in here. So here is one. You gather your own quotes. I did a Google search on them, so it's not really much anonymous. So you can have your own. And then there's another one. I think I missed the I. And then another one. And then the last one. And the last, just for me, feel free to add more. One of the beautiful things about isolating the data in a file from the controller is you can change the data anywhere you want, and you don't have to touch the controller, and everything will work. So if you add other values, or add, and I added here 5, if you add 10 or 11 or 12, nothing in the controller will change, and that's because we separated them. Had we hard coded the data in the controller, this would not have been the case. So now let's open the controller and take a look at it. This is our first time together to look at the viewController.swift class, and welcome to programming, part of software development. And in programming, we provide instructions on lines, and I added the line numbers in my editor, and I made the fonts bigger and so on for all of you to see. If you want to play with the preferences of the editor, you go to File, and under not File, to go to Xcode, and under Xcode is Preferences, and under Preferences there is Font and Color, and then there's different themes, or you can create your own theme. You can also go to Text Editing, and in Text Editing here is the line number, so you can have the line numbers, code folding ribbon, and that's the one that I just added here. It's the ribbon to fold the code, and and then you can look at all the different other options that are available to you here in the edit or in the font and color. So that's for the preference. Now let's take a look at the code, and step by step. The first thing is you see stuff in green. Notice two things about the green. First, it starts with 2 slashes. Second, it's ignored, but not ignored, it's called comment. A comment is a line of instruction that is ignored by the operating system when it processes what you want the computer to do, what you want the computing device or computing unit to do. Meaning that the operating system or the computing device, when it tries to interpret, or the platform, the iOS platform, when it tries to interpret the instructions you provided in this code, it goes sequential from the top to the bottom. So it encounters an instruction that starts with 2 slashes. It immediately recognizes that that instruction means a comment, so it ignores it. It doesn't try to interpret it or try to execute it. Then it keeps going. That's another comment, so it skip it, another comment, and so on. Then it comes to this. This is an empty line, which is fine. You can have as many empty lines as you want. Then there's an instruction called import. Xcode colors it for you, and that color, the pinkish reddish color, it means it's a keyword. It's part of the language, part of the grammar of the language, if you can say, or we call it keywords of the language, meaning you cannot use it for something of your own. And then the next, so import meaning bring in the content of something different from this file. So this is an independent file, and that file needs to access the UI kit, the framework for user interface. So it imports the content of the UI kit into this. So the first instruction to the operating system or to the platform is to say import all the content of the UI kit framework into this file. Then an empty line. Then you have the other instruction which says class. Let me fold this. A class is a unit of code. So that's what a class is. Once it encounters the class unit, it means that you are about to define a unit of code, a unit of software, or a type that the operating system will then need to address. Now that type is named view controller. So what you see in black is a name that we provided. So that's a custom name. The colon means that we are not creating a new unit of code or a new class from scratch. We are creating it based on something else. So the colon means based on or inherit from, meaning that extend the features of something else into what we're trying to create. Basically means we're not creating from scratch, we're building on what somebody else have done. So where are the content that we're building upon? It exists in a class called UI view controller. It's in purple, meaning that this is a recognized library class. It's a class in the library in the UI kit. This is why we imported the UI kit. UI view controller is the default controller for any view controller. So this is what has the default behaviors that allow you to close a screen, to open the app, loads the app, manages the interaction of the app inside your operating system or inside the operating system of your device. These are default behaviors. It happens anytime you load a screen or a view into a device, regardless of what the view will do. So these default behaviors are already written into a library class called UI view controller. To avoid having to redo all of this on our own and spend a lot of time and effort and maybe make mistakes, we do not create a controller from scratch. We create a controller that already has these default behavior by extending and inheriting the UI view controller line. Then there is a colon or a brace, a curly brace, an open and a close. The curly brace represent the body of the class, the content of the class. So that first line represent the identity of the class, the type, which is a class, the name, and the parent of the class, or what this class is inheriting from, and what goes between the curly braces represent the body of the class. Now let's open it. When you open the curly braces, you see in this class, and I'm gonna fold these two, you see there are two functions inside the class. Actually, this class has so many other things because it has everything exist inside the view control. But we don't have to display them here. We only need to display the ones that we will change or we will override. These two functions are very common. They are connected to common events, built-in events that most people will address. The view did load event and the did receive memory warning. If the device has memory issues and you want to do something before it crashes or the device shuts down or something, you can put the instruction in that function. Notice the keyword function that defines the type of this component. This line and this line are similar in that it has the type of that piece of code, it has a body, and it has a name. So this is a class and this is a function. A function is a member of a class. And a function represents a specific responsibility inside your class or inside your software. It has a body, that is defined between a curly brace, an open and a closed curly brace. The override, meaning that this function is defined already in the parent of the class in the UI view controller. So when you change it, you have to put override so that you know this is not a function that you created. It's a function that's already created in the UI view controller and you're just making changes to it. Now let's open that function. Inside the function, you see a line of instruction. So this is the first line of instruction that's going to go to the computing device. And that line of instruction says, execute the content of the function viewDidLoad that exists in the super. What is the super? The parent, what you built upon. The super here is a keyword that references the memory location for the UI view controller object. So this, what we have here in a class, this is our physical world. I mentioned earlier in a previous video the distinction between the physical world that we have and the digital world for the app. The app does not run in our physical world, it runs in the memory of the device. So we are not in the memory of the device right now. We're in our physical world. So we're defining what should be inside the memory. But once this is loaded into the simulator, it is in the memory. So in the memory, there will be what we call an instance of the parent and an instance of this class, an instance of the view. Every component that I am defining, an instance of that will be created in memory, and they will collaborate together based on the instructions that I'm providing here. So the first instruction, I'm providing a custom instruction because this project already contains some built-in instructions. That's what allowed our previous iteration to work. But now this is my custom instruction, is to execute. Since I overrode the viewDidLoad, I want to execute, make sure that whatever was predefined in viewDidLoad is executed first. And that's what I do with super.viewDidLoad. Then it tells you, now here is some stuff that you have to do first. So now what do I need to do? I need to load the content of the file into the NSArray array, into an NSArray type, right? So this means that I need to access the file and I need to define the NSArray. So to define the NSArray, I can define it inside the body of the function or inside the body of the class. This is a very, very important distinction, and I will repeat that forever throughout the series. Every time you define a type, define a type or instantiate a variable from the type or a concept, instantiate an object or instantiate an instance of the type, the scope of that instance depends on the body in which you define it or create it. So I want to create an instance of the NSArray type so that I can load the content of the file in it. If I do it here inside the viewDidLoad function, I can only use it inside the viewDidLoad function. If I create it inside the class, the body of the class, I can use it anywhere inside the body of the class, meaning I can use it in the viewDidLoad function, but I can also use it in any other function. So I will add that outside the function, so inside the body of the class. So outside the body of any function, just to emphasize this, I'm gonna fold all the functions so you can see that I am defining an instance of the NSArray type to have the scope of the entire class. So I use the keyword var, and this means that this instance can change its type. And then I give it a name. So I will call it quotes. Then I can specify a type. So I use a colon and specify the type NSArray. Then I can give it an initial value. So I say equal, and then if I want to initialize the array, I can, and notice how Xcode is very smart, I can initialize it with one of the initializers of the NSArray. When I type the name of the library and then use a parentheses, I have access to all the initializers. So these are all the initializers. One of them is called a default initializer. This one initialized with another array. This one initialized. So each one of them initialized differently. This one a default one. So I can initialize with a default array like this. So now what this line of instruction did is that it says I want to allocate a space in memory. I will name that space quotes, and that space will be of size comparable to an NSArray type. And I want to initialize that to whatever returns from the default initializer of the NSArray. And this quote can be assigned, can be variable, can change. The content in it can be reassigned later on in the program. This is why I have the keyword var, because it means I can reassign that to something else. So now that I initialize this, I can go and create the code or create the connection to the file and load the content of the file inside quotes. Now, so let's to load the content of the file. The first step is I need to get a reference to the bundle of the app. The word bundle means folder. When this app, remember, this is the physical universe. When the app goes to the simulator or the phone, the app will be located inside a folder. I don't know where that folder is. Every instruction I put here will be executed in the device. So as if like I'm creating something in one universe, but it will work in another one. Think about a designer, somebody who designs cars or clothes or anything. The designer may be in New York, in California, or in Cincinnati, but the factory may be in another city or another country altogether. So the designer defines the properties, the attributes, the features of the item, whether it's a car or a clothes or a product. Then he ships that or loads it into the factory, and the factory, that's when it takes a place, and it could be completely different place. So the same here, we're here defining, and then it will go to the simulator. So I don't know where the app will be in the simulator, so that's where I need to access the folder. So we'll go to the folder here, and the folder is in something called NS bundle. So I can call the NS bundle, and NS bundle. This smart editing give you the name of the library, the type, and what it is. It's a class, it's a variable, it's a method. So this is a class NS bundle, and there's a function there called main bundle, and that function returns an NS bundle, returns the directory where the current application executable is located. So I want to get that bundle, but that bundle gives you back something. It gives you back the reference. So in order for me to be able to use the main bundle, I have to assign it like I did here. The NSArray returns an initial array. If I don't assign it somewhere in memory, then I will not be able to reuse it. So here to the left side of this, I need to add something similar. So I need to say var, and then I will give it, maybe I will call it the app bundle. So I need to give it a name, and then I can give it a type NS bundle equal, and then NS bundle main one. So now I created another instruction, and that instruction is very similar to this instruction here, that it says there is a variable, a memory location that is variable. We're calling it app bundle. The type of it is NS bundle, and we want to assign to it the value coming from the function main bundle in the NS bundle library. Now you will say, how did you even think of that? Well, that's why I'm teaching the class. So I'm introducing you to all of this. After you finish this project, now you will know where are those libraries, are what that whenever you need a reference to the library or the app bundle, this is how you get that reference. Now let's look at that warning that is coming to us here. It says the bundle was never used. Consider replacing it with something else. So it's saying that you really never used this. So do you want to create a memory location for it? That's what this is about. Do you want to create a memory location for something that you never used? Now, I know that I'm going to use it, so I can ignore this. But before I ignore it, the Swift programming language is very smart. It says what? On the right side of the assignment operator, you say that you're going to use an M main bundle. So let me show you this again. When you hit the dot main bundle, what's to the left? It says NS bundle, meaning that the type of the data that the main bundle function gives you is NS bundle. So if the type is NS bundle, why do I have to say it again? So Swift says, I already know that this will give you NS bundle, so you don't need to tell me. So specifying the type like that is not needed. So I can take that out. Why I take that out? Because Swift has what's called type inference. It infers the type from the right side. You will say, well, can I do that here as well? Yeah, you can do that here as well. You can take the NS array from here all the way out like that, and it will still work. Let me leave that for demonstration. Now, let's then go to the next step. So now that I have the bundle, what do I need to do? I need to get a reference to the file that I want to open. So now I have a reference to the folder. Now I need a reference to the file. So the file itself, when I get the reference for it, in memory, I'm not going to change it. So instead of using the var keyword, I can use another keyword called let. Let and var, both of them creates location in the memory of the device, in that digital universe. The difference is, if you create a memory with var, you can reassign or you can change its content. If you create it with let, the content is fixed or constant. So I can say let file path equal, and then use the app bundle and say, I want the path for resource. This function here, path for resource, which gives us back a string, and notice that question mark next to the string. We're gonna deal with it in a moment. And you provide the name of the file, the extension of the file, and it gives you the full path to the file. So here the name of the file, it needs a string. To provide a string name, we use the double quotation. So the double quotation and say the name of the file. This is the name of the file, the resource file, exactly as it is, case sensitive. And then hit tab to go to the other variable. It's also a string. And here the extension of the file, which is plist. Again, it's the plist is case sensitive. Remember when I said the path for resource give you back a string with a question mark? So the question mark means that this is an optional, a string. So the string can be null, meaning that you can go and not find the file, so it will give you back nothing. In order to ensure that I retrieve a file, whenever you see the question mark on the type, and if you forgot where it is, it's here. When I say path for resource, here is the question mark. It says that it's not giving us a string. Remember, the NS bundle didn't have the question. It guaranteed to give you something of that type. When you see the question mark, it means You may get the string or you may not. So the exclamation mark ensures that you're going to get something, and if not, it will give you a nil, and then you can check if you want to do something with that nil or not. So here I'm going to put the name of the file again because I took it out. So here's the path of the file. And now that I have the path of the file, I say load the contents of the file into the array. So how do I do that? I say quotes equal. So which means that assign to quotes. Now I can assign to quotes. Why? Because I made it var. Had I defined quotes with let, the compiler would have objected to that. So I will say I want to initialize an array from the content of those files. See, one of the initializers says it's a content of file, and it needs a string, so I can provide the file path as a string, and there was a question mark here, so I add that as well. So now I loaded the array. Oh, and I forgot the question mark here. So that gives me the content of the file. So that initializer opens the file, load its contents, and organizes it, formats it, does whatever it needs to do, and gives me back a full array in the index as a column in a table like that. Lastly, you see this warning is still here, and it says that the variable never changed. Fix it, replace the var with let. Swift is a very strong typed language, and they put a lot of emphasis in the language on managing the memory and forcing programmers to best practice. One of the best practices, if the variable or the memory location that you're creating will never change its data, then don't use var, use let. And that's what this warning here is telling us. And it says consider it, meaning that it's just a warning, it's not an error, so you can ignore it, but it gives you here suggestions to what to do. So let's follow the suggestion and say replace, so it replaces it and everything is good. I will stop here because this video has gone way too long, and in the next video, part 2 of this, we will continue we will generate the random code and display that random code.